Hey Intellect reviewers, welcome back to the Intellectory channel. Today's topic of discussion is going to be the definition of the derivative in calculus, but a visual depiction of it. So we can truly understand not only what the formula is for it, but also a graphical description. So here we have a graph that I've drawn along with several other components. And some of the most important components to see here and notice are the tangent lines. So the tangent lines are found right here, right? And right here, and you can draw them almost anywhere on the graph of f of x here as you want. But the important thing to realize there is that these tangent lines I've specifically drawn because the slope of the derivative here is 0 from the graph of f of x. Because we know that when even drawing or sketching derivative graphs of functions given to us, whenever on a function's graph, f of x or g of x or whatever function it may be, there is a kind of slope of 0 here, then, that means there's a slope of 0 for the derivative. So the derivative slope is 0 over there. So the derivative is 0 over there. So the derivative graph, there would be a 0 right here and a 0 right here, based off of the graph of f of x and the 0 slopes. So apart from that, there are some other things to notice. So first of all, let's define a tangent line. A tangent line is a line that represents what the slope of a point is on a function's graph, right? It's used to represent derivatives, right? How fast is something moving on a function's graph, right? We can describe those things utilizing tangent lines on a function's graph, and that shows us how to graph a derivative as well. So apart from that, we can look at other things here where we have 2 points. One point is x sub 1, and another is x sub 1 plus delta x. So here, both of them have their corresponding y values. So for example, if we plug in, let's say, this point x sub 1 into this function f of x, we get the output or y value x sub 1 comma f of x sub 1, right? The x comma y, you know? So, and then for the point x sub 1 plus delta x, we get the y value of f of x plus delta x, and then the x value is obviously this itself. So those are the corresponding y values and x values that are found in this graph, and these are really important components that come into the definition, so that's why it's important to pay attention here. So now it's interesting to notice that here within this, between these 2 points, there is a distance that we can denote or define as delta x. So between this point x sub 1 and between this point x sub 1 plus delta x, well, why is this point specifically x sub 1 plus delta x? Because this point is an delta x distance farther apart from this point x sub 1. This is why, therefore, it is x sub 1 plus delta x, not x sub 2, x sub 3, or whatever notation it may be. So apart from that, I've drawn dotted lines where, they are. And another important part of this graph is when we're noticing the x and y values, that the y values of these points, right, match up to these points right here. And so there's a line going through them. Now, that line is called the secant line, right? It's a secant line that shows the slope between 2 points on a function's graph. And it's really important to know as well. So apart from that, we have these two kind of points here, or y values here. So there's one f of x sub 1, and there's one f of x plus delta x. So each of them kind of match up to the height of the y value. So this one kind of matches up to where this point is, but on the y-axis strictly, and the same for this one. And so again, this is really important to notice, but also let's refer back to the limit definition of the derivative. So the limit definition of the derivative states that a derivative of any function can be found by finding the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So a description of this definition and this whole entire graph, we can say, is as the distance, right, delta x between 2 points, x sub 1 and x sub 1 plus delta x, which is delta x, right? This distance we refer to as delta x is decreasing or approaches 0. The y value of point x sub 1 and x sub 1 plus delta x divided by delta x will get you the derivative of the function at any point, right? And again, the derivative is the rate of change at a point, or it can also be defined as the instantaneous rate of change, right? What does that mean? That basically means how fast is something moving, but at a point on a function's graph, rather than slope, which is just a general approximation of rate on a function's graph. So thank you guys for watching. And again, one more thing to refer here is the point of tangency. So the point of tangency is basically the point where a tangent line is established or met, or when it meets a function's curve. So here I've drawn two tangent lines here where it represents there is 0 slope, right? So they're basically lines that you draw to represent slope on a function's graph. They denote the following. So they can be denoted as the following, right? The point of tangency is right here for this point. The point of tangency is right here for this tangent line. So wherever the tangent line meets a function's graph or curve, you can say there is always going to be a point of tangency. And so it can be noted as x comma f of x, right? A normal coordinate point, given a slope defined or described by a derivative f prime of x. So again, the derivative is the instantaneous rate of change, so the rate of change at a point, how fast something is moving at a point on a function's graph. Therefore, wherever the point of tangency is, right, there will be a tangent line that'll show us the slope of the derivative itself, right? How fast the derivative is going at a rate of whatever rate it may be. And yeah, so thank you guys for watching. I hope you guys learned a lot about the definition of a derivative, and not only the algebraic definition right here, or the verbal definition of a derivative, and not all these definitions, but the visual description of this graph right here can really help you truly understand not only the analytical algebraic side of this, but also the graphical and more visual side of it as well. So thank you guys for watching. I hope you enjoyed this video. Please don't forget to like, share, and subscribe to the Intellectuary channel so you don't miss any important updates when I post new videos on calculus or any other topics as well. Thank you guys for watching. Make sure to not miss out on any other videos as well, and watch other videos on my channel. Thank you.